Okay, so we are almost completed with this section of notes with 1.5. We finished up yesterday with completing the square, and today we're going to do quadratic formula. And the quadratic formula, we need to have our trinomial in standard form, which is ax squared plus bx plus c equals 0. And we are going to use the formula where x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It is important to note that this portion of our equation is known as the discriminant. And we'll get into what is important about the discriminant in a little bit, but first we're going to go over an example or two using the quadratic formula. So for the first example, we are going to do x squared minus 10x plus 25 is equal to 0. So our a value is 1. Our b value is negative 10. Make sure that you keep the signs with it. There are lots of places that you can make mistakes in here, so make sure you're watching your signs. And our c value is 25. Okay, so our equation then is, I'm going to take this, copy, and let's paste it down here. I'm going to get rid of that purple box. Would have been easier just for me to rewrite this, but we're already committed now. Okay. So my b value is going to be that negative 10. So I'm going to replace b with negative 10. And then I'm going to do that for both of our b values. A, we said, is 1. So I'm going to replace a with 1 in both locations. And then c we have is 25. At this point, you could just throw this into your calculator. I'm going to do it by hand. You don't have to, but I would throw it in your calculator. So I have a negative 10, which is going to be positive 10, plus or minus the square root of negative 10 squared, which is 100, minus 4 times 1, which is 4, times 25, which is 100, all over 2 times 1, which is 2. Simplify that, and you're going to get the square root of 0 over 2. Simplify that, and we have 10 over 2, which is 5. So here there's only one solution, also known as the root or 0 of 5. And that is the first example. If you need any of that work, you can go back, pause it, write it down. And we are going to go to another page and do another problem. So the next one is 2. I have 2x squared plus 3 equals 7x. I need this to be in standard form, so I'm going to move that 7x to the other side. So I would have 2x squared. I'm going to shove that 7x in the middle here so it goes in standard form, equals 0. And now I can use my formula. My a value is 2, b is negative 7, and c is 3. All right, so my formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to replace my values. B is negative 7 plus or minus the square root of negative 7 squared minus 4. A is 2, c is 3. I almost ran out of room there. And then 2 times a, which is 2. And then we can go through. You can type this into the calculator. However, if you're going to type it in, only type in what is under your radical and simplify that piece so that everything will end up being kind of nice and pretty. You're going to want to keep any square roots that you might find. So we're going to have 7 plus or minus the square root of 49 minus 4 times 2, which is 8 times 3, which is 24, all over 2 times 2, which is 4. 7 plus or minus the square root of 49 minus 24, which is 25 over 4. So 7 plus or minus 5 over 4. So then I'm going to have two solutions. I'm going to have 7 plus 5 over 4 and 7 minus 5 over 4. We can simplify both of those. 7 plus 5 is 12 over 4, which is 3. And then 7 minus 5 is 2 over 4, which is 1/2. So my solutions are 3 and 1/2. We're going to go ahead and do 2 more of these just so you can see the different types of solutions that you might get. Number 3, we're going to have 3x squared plus 6x minus 5. So that makes our a value 3, our b value 6, and our c value negative 5. So I'm going to have negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm just keep writing that out so you can see where we're sticking these numbers. B is 6 plus or minus the square root of b squared minus 4. A is 3. C is negative 5 all over 2 times a, which is 3. So I'm going to have negative 6 plus or minus 6 squared is 36 minus 4 times 3, which is 12. And then I'm going to have 12 times that negative 5, which is negative 60. So I have minus negative 60 minus a negative is really adding. And 2 times 3 is 6. So I'm going to have negative 6 plus or minus the square root of 36 plus 60, which is 96 all over 6. 96 does have a perfect root, so I can simplify that radical, not the fraction quite yet, to being 16 times 6, because 16 is a perfect square. And the square root of 16 is 4 all over 6. And now I'm going to have my two solutions. So I have negative 6 plus 4 times the square root of 6 all over 6. And I can say negative 6 minus 4 times the square root of 6 all over 6. These do simplify because I could divide everything by 2. So when I do that, I'm going to have negative 3 plus 4 times the square root, not 4, 2, all over 3. and negative 3 minus 2 square root of 6 all over 3. Those would be your solutions. You could write this as one solution, so you could also write this as negative 3 plus or minus 2 times the square root of 6 all over 3. So you could just write it as one, or you can write it as both. Either way is fine. Last example, so that you can see another type of solution you might get, is going to be 5 over x minus 7 over x squared equals 2. So first off, this is not in standard form. So I need to fix that first, and I can do that by multiplying everything by x squared. So I'm going to have 5 over x times x squared minus 7 over x squared times x squared equals 2 times x squared. My squared cancels here, so I'm left with 5x. My numerator and denominator cancel on the next term. And then on the other side, I'm going to have 2x squared. This is still not in standard form. I need to move that 2x squared to be with everything else. So then my equation that I'm going to use is negative 2x squared plus 5x minus 7. There's plus there at the beginning because it's not negative, so I know that it's a positive 5x, and that's equal to 0. Now I can use my equation. So negative b plus or minus the square root of b squared minus 4ac all over 2a. My a value is negative 2, b is 5, c is negative 7. So negative 5 plus or minus the square root of 5 squared minus 4, a is negative 2, c is negative 7, all over 2a, which is negative 2. Go ahead and simplify that. We're going to have negative 5 plus or minus the square root of 25 minus 4 times negative 2 is negative 8 times negative 7 is 56 all over negative 4. So I have 25 minus 56, which is going to give us negative 31 all over negative 4. And we know that we can't take the square root of 31. There's no perfect root for 31. Or perfect square that goes into 31, but I can take that negative out by making it an imaginary number. So I have negative 5 plus or minus I times the square root of 31 over negative 4. Because I have that I, I'm going to want to write it in that a plus bi form. So there's no real solution, but I'm going to change it to the a plus bi form that we used with our complex numbers. So I'm going to have negative 5 over negative 4 plus or minus square root of 31 over negative 4i. And since I have a negative over a negative, that can simplify to be just 5 over 4 plus or minus the square root of 31 over negative 4i. So that's the form you're going to want to write it in. I think there's one question maybe like this on the homework. I don't even know that there's just one. There might be none. So I told you at the beginning when I gave you the formula that there is the discriminant. So the discriminant is everything that is under the square root. So it is your b squared minus 4ac. And your discriminant actually controls what happens with your problem. So if b squared minus 4ac is equal to 0, then you're going to only have one solution. And that is like problem number 1. Or that example 1 that we did together. If b squared minus 4ac is greater than 0, there are going to be 2 solutions, which is problem 2 and 3 that we did together. And if b squared minus 4ac is less than 0, then there are no real solutions, but there would be 2 complex solutions, which would be problem 4 that we just did. All right, moving on, we're going to talk about some equations in quadratic form. So sometimes we're going to have non-quadratic equations, which just means that we don't have necessarily an exponent of 2, but we can still use it to solve. We can still use some of our quadratic methods to solve some of them. So for example, let's solve 5x to the 4th minus 3x squared minus 2. And we're going to to solve this, we're going to first solve what would happen if we had 5u squared minus 3u minus 2 equals 0. So essentially, we are pretending that u is equal to x squared. So if I put x squared back in here, then we would have x to the 4th, which is what we started with here. So that's where u came from. So when I go to solve this, we can factor that. And we can factor it with our table, because I know that's how y'all prefer to do it. So I have the 5 times a negative 2. Which gives me negative 10, and I want my factors to add or subtract to be negative 3. So I know that factors of negative 10 are negative 5 times 2, which gives me negative 3. U squared minus 3u minus 2. We're going to separate that 3u into 5u and a positive 2u. 5u squared, factor by grouping. That would be u minus 1, can factor out a 2, u minus 1. Because these are the same, we are good to go with that as 1. And then the other factor we're going to have is using our other 2 leftover terms, plus 2. So I can solve this 2 of those equations. So I'm going to have u minus 1 equals 0, and 5u plus 2 is equal to 0. So u equals 1. And 5u equals negative 2, which means that u is also equal to negative 2 over 5. So I know, though, that I changed some stuff out at the beginning, which means that I need to go back and kind of undo what I did. So I know that I had u squared, sorry, u equals x squared. Let me do that. Equals x squared. So I'm going to replace u. Let me come up here. So I'm going to have 1. I'm going to replace u with that 1 that I found. And then I can take the square root of both sides, which is just 1. And it is the positive or negative version. So that is one of the solutions. And then the next one, we're going to do the same thing, that u is equal to x squared. And I am going to replace u with what I found u to be. Take the square root of both sides, which leaves me with a complex number. So I'm going to have I times square root of 2 over 5 equals x, and it would be the positive and negative of that. I don't typically want a square root in the bottom, but I know that I'm going to use this solution because we don't typically use non-real numbers or complex numbers for solutions to things like this. And if I'm not mistaken, there is no questions like this in the homework. I'm going to check just to make sure. No, there's not. So I'm not even going to finish this section. And if you're watching this, that means that I decided to not cut it out of the video. Sorry, I didn't cut it. I am going to go over applications. So applications are next. So the first one, the length of a rectangle is 14 centimeters more than the width. The diagonal is 26 centimeters. Find the length and width. So let's draw ourselves a picture that will help us out here. So I have a rectangle, and it says that the rectangle is 14 centimeters. The length is 14 centimeters more than the width. So the width plus 14 is going to give me my length. And I'm told that the diagonal is 26 centimeters. From Pythagorean theorem, you're going to have a squared plus b squared is equal to c squared. And that is going to help us out because our c squared is our hypotenuse. And then the a squared and b squared are the length and the width of your triangle. And you use those with a triangle. So that means that this is going to be c, and then a and b. It doesn't matter where a and b are. You could switch them. You would get the same thing. So a squared plus b squared is equal to c squared. So I can rewrite this as w plus 14 squared plus w squared equals 26 squared. So when I do that, I'm going to have to FOIL or use the trick that I showed you, which I'm going to do just to save a little bit of time. So I'm going to square the w. I'm going to square the 14. Nope. Got ahead of myself. And I'm going to double the 14 for what goes here. So that is 28 and add a W. 14 squared is 196. So I'm going to go ahead and replace that. Plus W squared, and 26 squared is 676. Combine like terms. I'm going to go ahead and change this so it's set equal to 0. Sometimes you're going to see that a number goes into all of these very nicely. In this case, 2 goes into 2, 28, and 480. So I'm going to factor out that 2 because it's going to leave us with some smaller numbers that might be easier to work with. You can use your chart to factor. So I want factors of 240 that add to be 14, and that would be 24 times negative 10. So I'm going to keep that 2 on the outside. Because my coefficient is 1, I don't need to factor by grouping or do that extra step. So W plus 24, W minus 10, and then I can solve. So I have W plus 24 and set that equal to 0, and W minus 10, and I can set that equal to 0. Solve for W. Once you get to here, you should be able to see that this would not make any sense. You can't have a length that is negative. So we're going to go with the width being 10, and I'm going to plug that width in up here of 10 to give me a length of 24. So my length is 24, my width is 10. We're going to do one more application problem, one more application problem, and that will be it. So number 6, use the formula S equals 16t squared, where S is the distance and object falls from rest in feet, and t is the time in seconds. To find the time it takes an object to fall. Find the time it would take for an object to fall 196 feet. Okay, so we are looking to find t when S is equal to 196. So I'm going to change my formula. I right now have a formula of s equals 16t squared. I'm going to rewrite that with s being equal to 196. I need to divide both sides by 16. Which is 49 over 4. And then you can take the square root of both sides to get rid of that squared. The square root of 49 is going to be 7, and the square root of 4 is 2.